Hello and a wonderful day to everyone, and welcome home, sort of, in the domestic economy. After having traveled the world theoretically with globalization and other aspects, we are now looking at the theory that that is also the base for some of the international theories we have been discussing and the international realities we have been looking at. The theory of expenditure and fiscal policy. Fiscal policy, what can the government do in order to stimulate the economy, in order to smoothen the frictions in the economic development? So that will be the topic of chapter 13. It has two parts. In this first part, we look at the theory of, at the end, the Keynesian theory, the Keynesian cross, thinking about how we as consumers, or how consumption on a national level influences the development. Our chapter 13 is divided into these 8 sections, where, as you know, typically the first sections are the bigger ones, the most important. This first video is about the first two, 13.1 and 13.2. Especially 13.2, consumption, investment, expenditure, and the business cycle. And that's the basis of the Keynesian theory that we are going to talk about. Then the second video about this chapter 13 will be about fiscal policy, what can the government do, and some applications, especially at 13.6, we're going to have a bit of a look in direction of debt funding and crowding out. What are these concepts? What do we do with those ideas? Learning objective, I already said, the Keynesian cross, and we are going to see why it's called the Keynesian cross, or the Keynesian income expenditure model. It's the more formal name, because again there will be lines crossing, and we learn something from the point where they intersect each other. The multiplier will be an important part of what we discuss, because it's a crucial part of the ideas of Keynes, seeing that the government can sort of put a small stimulus into the economy, and that might end up to be a relatively larger effect. These two are part of this first video. Then in the second video, when we talk about fiscal policy, the balanced budget and the balanced budget multiplier will be topics that we talk about. Yeah, from business application, of course, it has to do something with taxation and business spending, government deficit, what are the implications for business, and the concept of crowding out that I already mentioned. We're going to learn about these topics and what they mean. So who's spending and where? With this, we come at the end back to what we called the expenditure method of calculating the GDP. And we hopefully recall y equals c plus I plus g plus x minus m plus the balance of international trade. And so we come back here, and that's in fact a starting point for the Keynesian theory. Yeah, names here or concepts that we are going to talk about. We're going to talk about mostly consumption as a part of what Keynes calls the planned expenditure. What are our plans on an aggregate level? What is it that we want to buy, that we want to consume on the one hand, but also that businesses want to invest? And these together is going to bring us to the multiplier. When we think back a bit to our comparison of the different schools of economic thought, we have the classical, neoclassical, or neoliberal idea to leave markets alone versus the Keynesian idea. And when we think about this theory of leaving markets alone, markets organize themselves, then one basic idea underlying this theory is that everything sort of is optimized in a way like we learned in microeconomics, typically making functions and then finding the maximum of this function, the optimal decision, the optimal consumption decision, the optimal production decision, which price results from this, and so on. If you sort of aggregate this from the micro level up to the macro level, to saying, if we let everyone optimize for herself and himself, then also the macroeconomy is going to function. And that, in fact, didn't work all the time. We already have been talking about the historical background of Keynes theory, that this was the Great Depression in the 1930s, where obviously that model didn't work. And so he thought about it and he came to the idea, obviously it's not, at least not only the supply. There have to be good conditions for the supply, for the enterprises, free markets, and so on. But that doesn't always do the job. If there's not enough consumption, if we don't spend enough, and if the firms don't invest enough, so if our planned expenditure, this is what we have up here, our planned expenditure are not high enough, then the economy cannot develop, and we might end up in at a national output, a GDP, which is lower than if we were sort of more optimistic, or if there was more private demand. And this is the background to the model we are going to learn about now. The Keynesian cross talks about the equilibrium where planned expenditure, aggregate is again on a national level, all the consumption, all the investment, all the government spending, where this planned aggregate expenditure is equal to the actual output of the firms. So all the goods and services produced by firms, that's our definition basically of GDP. So if we really sort of buy the GDP, if firms in an economy produce a specific level of, let's say, $4 billion, and we only buy $3.5 billion, then these firms at the end also are not going to keep on producing this amount, but they're only going to produce that amount that is in fact demanded by us, by the households. And that's the idea, that's what we are going to talk about. Planned expenditure is the total amount of spending on goods and services within the economy that is planned by the purchasers. This concept of equilibrium in this definition, equilibrium is where the planned expenditure is equal to the actual output, is somewhat different from the concept of equilibrium that we have been talking about. When we look at the figure, we see that it says possible equilibria, the 45-degree lines. And that's a graph or a type of illustration that sometimes seems a bit strange. I mean, we know what a 45-degree line is. A 45-degree line describes the points where the value on the horizontal axis is the same as the value on the vertical axis. The vertical axis contains the planned expenditure. So these planned expenditure are basically consumption as the biggest part, as well as investment and also government spending. So the parts, the domestic parts at the moment for a closed economy without looking at international trade that we used as expenditure approach or use approach to compute the GDP. So this planned expenditure is on the vertical axis, PE, and on the horizontal axis you see output income. That's our Y. And we might keep in mind from our thoughts about national accounting, how to compute the two things, that they are at the end equivalent, that the output or the production and the value of all the produced goods and services is the value that is created within an economy, and that we take this as a proxy also for the income of an economy. So when we continue our analysis, we need this diagram where we have the planned expenditure and the Y, which is the output. Now, our first point is, the first step is to ask ourselves, what is consumption? What are the determinants of consumptions? How do we aggregate, we, all the consumers in an economy, how do we decide how much to consume? And the way this consumption function is modeled in the Keynesian cross model, he says consumption basically comes from income. When we have income, we have the possibilities to consume. If we have high income, then we can consume more. If we have low income, we can consume less. And that's a contradiction to the neoliberal model, where also the consumption decision is based on optimization, is also based on optimization. Let's say at the beginning of the month, we receive our money, and then we first of all check in a rational way. For example, does it make sense to save? What are the conditions on the capital markets? What is the interest level? And then we decide this. And then at the end, there is also consumption is one part of our spending. Keynes contradicts here and says, basically, it's our income that determines our spending. And this function does have two parts. You can see this here. One is called autonomous consumption, and the other is called marginal propensity to consume. The base number is our disposable income. And again, you might recall from chapter 9 and chapter 10, at the beginning of chapter 10, where we looked further into how to measure national income, that we differentiated income from GDP as a production measure. Frequently, we are going to take GDP here also as a proxy, but the theoretical basis is the disposable income, nevertheless, that we are going to describe as Y and take sort of the output Y as a proxy for the income. But what are these two, autonomous consumption and marginal propensity to consume? This first part, see, autonomous. The term autonomous is used here in the way that it doesn't depend on the income. That there's a part of our spending, of our monthly spending, weekly spending, or whatever, that we have to do. That doesn't depend on whether we have a high income or we have a low income, or even if, let's say, we lose our job and we are unemployed and we don't have any income, we still have to pay our rent. We still have to buy basic food in order to survive. We still have to buy basic essential goods, as we call them. So that is something, a starting point. And on basis of this starting point, we have the part that depends on the income, that is called MPC here, the marginal propensity to consume. And that's at the end a percentage. If we earn €1 more, which percentage of this are we going to spend? Are we going to spend half of it? Are we going to spend 80% or everything, whatever? That is an important part in the analysis. And it contains the term marginal, so percent of from one extra euro income that we receive, this percentage that we spend. Let's emphasize this extra, as we recall that this is our definition of marginal. At the margin was something we have been discussing. One more, if we receive one more unit, if we receive €1 more of income, then there is the question, how much of this do we actually spend? And at the same time, if you look at this function, it's something like C equals A plus B times Y, then we can say that this MPC is the B, is the slope of our consumption function. And this is then our function. It has a positive slope and it has a starting point that in math we sometimes just call A, and here the name is C autonomous. And the slope of the line is defined by MPC. So when we do our triangle, our rise over the run, that defines the slope, and we go 1 to the right. If we increase Y by €1 income, then MPC describes the percentage, describes how much of this are we going to spend? And that's it. That's the Keynesian consumption function. Generally, Keynes puts an emphasis on demand, as we already discussed several times, on consumption, private consumption. And that has also to do with the consumer satisfaction, whether consumers are positive, how the economy might develop, about their own income, the consumer confidence, as we say, as an important part of the economic development. In our book and presentation, we see the graph here with an example. C equals 7 plus 0.8 times y. So C autonomous has the value of 7, and the MPC has a value of 0.8. And when we look here, for example, what happens at a income of 100, then we can put this into their consumption is 7 plus 0.8 times 100. So 7 plus 80 gives us a planned expenditure, or planned consumption. First of all, we are at the first step. We are going to add the others, investment and government spending, later. A planned consumption of 87. In our book, you also find a bit of explanation about the consumer confidence. You find a picture about the British, and here this is a somewhat newer, more contemporary consumer confidence for the United Kingdom, for the euro area, for Germany. And you see this consumer confidence basically goes up and down, has different values that we look at. On this basis, we might and we should ask ourselves, is that model, this upward sloping consumption function, something realistic? Does it describe what we observe in reality? Can we see for the United States, for Italy, Japan, China, Germany, that this can be observed in data? And in fact, we do have this data. We already looked at the data, for example, from the Statistical Bureau, die Statis in Germany. They publish data, yearly data, quarterly data on the GDP. They also publish this data on consumption. And that, in fact, used to be the data source that we could rely on. We already used data from die Statis, from the Statistische Bundesamt, when we computed GDP, when we looked at measuring GDP in chapter 10. So that was usually what we have been using, but unfortunately the Deutsche Statistische Bundesamt, in its eternal wisdom, decided to cancel also this publication, last issue as an English version in 2023. And then when you follow this on the web page, you come to the German version where it says last issue in German in 2024. So these data are there, but it's not updated. That's why I searched data at another source, and that's the World Bank. There you have a wonderful database where you can check diverse data in time series. And these are the data that have been accessed here in November 25. So later you might want to follow these links. The one link is for the time series of GDP, the other is for the time series of consumption. And then we bring these two together in a graph, and you might decide for yourself whether you have the feeling, yes, this graph is relatively similar to the idea of Mr. Keynes, or whether we had to say, this graph is totally different. And of course, this is a rhetoric question. It looks quite similar to what Keynes said. Nevertheless, in class, we are going to analyze these data, and you can please start thinking about, how do I find the consumption function? So how can I be able to determine C autonomous and determine the marginal propensity of to consume? And that's not so much a surprise. A statistical means or a statistical method that you also learned in class. And we are going to perform this. So please think about it. How do we find the consumption function and how do we find, and that means how do we find C-autonomous and MPC empirically. So let's take this home or into class as a task, which we often do in these green boxes. Using the real data, how can we find it? That will be something that we do in class in Teamworks. Before we move on to the next element of planned expenditure, which will be investment, let's stay for a moment at this consumption decision. So when I have a specific income, an income of 1,000, and I decide to spend 800 from this, that means that the other 200 I don't spend. I save, at least in this model at the beginning where there is no government taxation and so on. I save. So at the end, my decision of consuming and of saving belongs together. And we will see that there is not only this consumption function, but there is also something we call the saving function. Let's have a closer look at this. We said that C-autonomous, this part here, represents the expenditure that we do, that we have to do, when we have no income, even if we have no income. When we think about saving, then in this situation, we obviously don't save. We do the opposite. We dissave. We have to either borrow money, or if we have money on our account, on the bank, then we take it out of our savings. That's why we call it dissaving. And here, this 45-degree line helps us to understand this relation. This line shows us that obviously until up to this point, up to this income, when we go down here, we in fact do not save, we dissave. And after that income, after sort of the income is higher than this point, we start saving. And always the distance between the 45-degree line and the actual consumption is our saving. So when we are here, this is the amount we have, this is the amount we spend. So obviously this part we actually save. That means that we can also draw a savings function similar to the consumption function. We can show these areas of dissaving and saving, or in fact, the shaded area then represents our savings, the amount of money that we put aside, typically on the bank. Here becomes bigger the more we earn. And at the same time, this intersection between the 45-degree line and the consumption function is that point where our savings become zero. Before, the savings are negative and then they are positive. And when we think about where do the savings start, then it's exactly the same amount C-autonomous, but to the negative side. So the function for the saving function is minus C-autonomous plus, and now we need the slope. If MPC is a percentage, 0.8, 0.6, whatever, and I spend 60% of my income, then obviously I save the other 40%. So the slope of the saving function is 1 minus MPC. And these two, MPC and 1 minus MPC, obviously have to add up to 1. Basically, we can say that we divide our income between consumption and savings, so that we can say y equals C plus S. And when we look at the marginal terms, then it's that these two have to add up to 1 or to 100%. As described here, this marginal propensity to consume plus marginal propensity to save is 1. If this is 80%, then that is 20%. If this is 50%, this is also 50%, and so on. We divide our income into these two activities. Okay, so now we sort of rounded up the consumption function by also looking at the other side, the saving function. So now that we talked about the consumption function, the next step is to say, yeah, okay, but our original idea was to talk about the planned expenditure, and the second part of the planned expenditure is investment. In fact, investment in this model does not depend on income, which makes sense. It's not the income that makes the investment. It might be more the interest rate, but that is an exogenous factor in our model here. That's not sort of on the axis. So the investment itself does not depend on the income. That means firms at the beginning of a period, at the beginning of the year, decide how much to invest in order to go on with their activities. And even if the income changes throughout the year, this investment decision is made. It's decided for 1 year, which means that in this model, investment is a horizontal line. It doesn't depend on income. And that's already the quite short story about investment. It's constant. It doesn't vary with the income. And as our goal is to talk about planned expenditure, we can bring this together with the consumption idea and the consumption function. If we have this consumption function, the example that we had earlier, 7 plus 0.8 y, it starts at 7 and has a slope of 0.8. Now, if we add the consumption of 50, the investment of 50, which would be the horizontal line here, 50 plus 7 is now the new starting point. C autonomous plus the investment. And from here, our planned expenditure function, which is in fact aggregate demand, consumption plus investment, goes up in a parallel way as it has the same slope. So that's how our first aggregate demand function that we develop from this idea of planned expenditure, how it looks like. Which we also have here in our graph, the autonomous investment up there, and then the aggregate demand from these two functions. We can also add the values here, which gives us the possibility to now ask for the equilibrium, because that was what we wanted to do. We discussed that the question is, how do we find, or which income represents the equilibrium? Equilibrium in the sense that the exact same amount is produced and consumed. And we said, okay, an equilibrium is on a 45-degree line. So if we add a 45-degree line to this diagram, we find the point of equilibrium. This 45-degree line represents all the points, all the combinations where y, the output on the horizontal axis, representing also income, is the same, has the same value as the demand, the aggregate demand represented by the planned expenditure. So we can see when we go up here that this 45-degree line intersects sort of the different lines, and this intersection is the important one where aggregate demand has the same value as the income y. So that's our equilibrium value. When we go down here, we can see the value. We could go to the left and we would have exactly the same value. But what is the value? At which value are these two going to intersect? Let us think about the functions that we have. The equilibrium is defined by supply equals demand. Y equals aggregate demand. Aggregate demand is defined by consumption and plus investment. That's this bigger line here, ADC plus I. And the consumption, the value for consumption, we had the example in the book is 7 plus 0.8 y. The example for investment is 50. At which value of y do the two intersect? When we look at this function, then we see that we have y on both sides. So it makes sense to sort this out, to bring y to the one side, to the left side, and then we can solve for the value of y that leads to an equilibrium. First of all, we can add 50 plus 57. 50 plus 7 is 57 plus 0.8 y. So now we bring this 0.8 y to the left-hand side by subtracting 0.8 y, and that leaves us 0.2 y on the left-hand side. And then we multiply both sides by 5, so we have y alone on the left-hand side, and we have to take 57 times 5, and that gives 285. These 285, this is the value where the two intersect, or more concretely, the value of y down here. So 285 here, and the same holds on the vertical axis as it's an equilibrium. So we have the equilibrium value if we know the demand function, we know the consumption function, we know the investment, then we are able to compute the equilibrium value, the value of y, where the two functions intersect. And that means that the planned expenditure is exactly as high as the income, which is where we use output as a proxy. Our book shows this also in figure 13.5, might be a bit nicer than mine, but tells the same story. So there's one thing more that we need as a basis in this first part of the video, and that is what is called the multiplier. The multiplier measures the change in output following a change in autonomous expenditure. And yeah, there is already some example down there, and let us have a look at this example in our board. So this multiplier asks the question, what happens if an autonomous part of the expenditure changes? Autonomous, in our case, what we have is investment. So let's say investment increases by 5 in our example. Delta I equals 5. This is going to produce a new aggregate demand function, aggregate demand 2, that is 5 higher. So it will be a parallel shift starting here at 62 and then go in this direction and again intersect the 45-degree line. We see a new intersection up here, or first of all down there. It goes up from 57 to 62, the change of 5. And when we observe this, we see that in fact the intersection does not only go sort of 5 to the right or up, but that it's far more than this. And that's what we want to analyze, and that's at the end the multiplier effect. A small change in aggregate expenditure, in one part of the aggregate expenditure of 5, and as a result, a large change in the equilibrium on both sides here. That's equivalent as we move along the 45-degree line. So with a small change in investment, we can induce a large change, a large increase, in fact, in income. Let us look at this effect more concretely. When we come from this, aggregate demand 2 is C plus I plus delta Y, and then we want to look for the equilibrium. Y is aggregate demand 2. Then we write this down. C, 7 plus 0.8 Y, plus I is the 50, plus delta I is the 5. So we can add this up, and it will be Y equals 62 plus 0.8 Y. And in the meantime, we know the story. We bring the minus 0.8 y to the left. So it will be 0.2 y equals 62, or y equals 62 times 5, which is 310. So we see we can put the 310 down here. So YE, the equilibrium Y2, 310, and then the same here. And you have access to the mirror board, so you can make it bigger and check the different effects that we have here. It's 310. So by increasing I, the investment, by 5, the equilibrium income increased by 25, 5 times as big. And this is the multiplier effect that we have to look at a bit more closely. We see the definition from the book that I copied here a second time. Multiplier is 1 over 1 minus MPC. And that is what we have to derive. Let's have a look. How can we write this down? How do we come to that equation? not using the numbers, but the signs that we had, y equals c plus I, or c autonomous plus MPC, then we have this function. The c autonomous, as the name says, is autonomous, and the y is autonomous. And this MPC has to do with y. It's MPC times y. And it's this y that we then again sort of bring to the other side. So we sort as we did before, and we subtract MPC times y. In doing so, we have the y parts on the left-hand side and the autonomous parts, both autonomous parts, on the right-hand side. So y minus MPC times y can be rewritten as y times 1 minus MPC. And this is now a part that we can bring to the other side by dividing both sides by 1 minus MPC. Dividing by 1 minus MPC means where I can multiply with 1 over 1 minus MPC. And this is now what we call the multiplier, 1 over 1 minus MPC. This multiplier is an essential basis of the Keynesian theory, as what we can see and already described, a small stimulus with increasing autonomous parts of demand, of aggregate demand or per planned expenditure, can lead to a relatively larger change in income. And that's what typically what we want in economic policy. We want to stimulate income. We want that people have more income, that more is produced. So in this little box, it already says here the example that we saw. The multiplier in our case, if MPC is 0.8, is 1 over 1 minus 0.8, which is 1 over 0.2, and that is 5. So our multiplier is 5. A small stimulus of 5 in aggregate demand leads to a large response of 5 times 5, of 25, in income. So much for the theoretical part. We are going to spend quite some time in class to discuss this multiplier, how does it work, and to practice, to compute different tasks. One hint is given in our book in this table 13.1 that shows an example of the multiplier. And I'd like to invite you to have a look, to try to understand on your own, read in the book, whatever, what this table wants to tell us, what it wants to show us. And next step is that we are going to discuss this in class and explain to each other what is this table about. We're also going to do examples, building an own table in order to understand this effect that with sort of one additional injection, we come to a far higher output. And then the next step in the next video will be, what does that mean for fiscal policy? So if the government spends more, because we said it's about a change in autonomous expenditure. And when we think about autonomous expenditure, it's investment. It's C autonomous, but that rarely changes. It's investment, and it's also government spending. So also the government can use this multiplier, and that will be what is going to be discussed in our second video about chapter 30. See you then. Enjoy economics.